All right, so we officially moved on to solving one-step equations. So remember, there are two different ways that we can solve these. We can solve them using tiles and we can solve them algebraically. So on this video, I will show you both ways. So let's start with number one. Number one says Casey has been to the park 3 more times than Kendall. Casey has been to the park 5 times. So how many times has Kendall, X, been to the park? So when I see a word problem like this, the first thing I want to find is what does my variable represent? And in this instance, X is representing the amount of times that Kendall has been to the park. So my answer choice is anywhere I see an X, I'm going to label it with a K for Kendall. Then I know, if I go back to my problem, that Casey has been to the park 5 times. So anywhere I see a 5, I'm going to label that with a C for Casey. So last bit of information is figuring out, well, what's the operation? So it says that Casey has been to the park 3 more times than Kendall. Now, normally when I read a problem like this, more times would signify that that is adding, but you're going to see in some of these problems that they try to trick you up by doing the opposite operation. So for us, we just need to be able to recognize that 3 more times is an additive word. So it could be adding or subtracting. So when I look at my two possible equations here, I have 3x equals 5. This is a multiplicative operation because I have that coefficient and a variable. And then I have x plus 3 equals 5. This is going to be our equation here because it's additive. I have Kendall. Casey has been to the park 5 times, so we've got to figure out how many times Kendall has been. So let's start with our tiles. Remember that this dark solid line down the middle represents our equal sign. So I need to draw what's on the left of my equal sign. So that would be x plus 3. So it's a positive x, so a long unshaded rectangle tile, and then 3 positive tiles, so 3 unshaded circles. Then on the right side is positive 5, so I need 5 positive unshaded circles. Okay, then remember our whole goal is we need to isolate x or get rid of what is bothering the x. So what's bothering the x right now are these 3 positive tiles. So to get rid of them, I have to put the opposite of 3 positive tiles, which would be 3 negative tiles. So 1, 2, 3. What I do on one side, I have to do on the other side. And then I can make my 0 pairs. So remember, 0 pairs are made up of 1 positive and 1 negative. So there would be a 0 pair, another 0 pair, and another 0 pair. So all I have on the left side is just my x tile that remains. And then on the right side, I can make a 0 pair, a 0 pair, a 0 pair, and I'm left with 2. So x is equal to 2. So if I wanted to solve this algebraically, I'm going to write my equation. Okay, I'm going to build my t-chart. So a straight line through the equal sign, just like we do over here, and a line underneath. So again, my whole goal is to isolate x to get rid of what's bothering the x. And right now, plus 3 is bothering the x, so I'm going to circle plus 3. I need to do the opposite of adding 3. So that would be like subtracting 3. What I do to one side, I have to do to the other side. So my 3's cancel each other out. So I'm left with x equals 5 minus 3, which is 2. So in order to check, I'm going to substitute in what I think the x value is. So my equation again, one more time, is x plus 3 equals 5. I'm going to substitute in 2 for x. So 2 plus 3 equals 5. 2 plus 3 is 5 equals 5. So check, we've got this one right. Then for my graph, I'm going to put a nice solid dot on, oh, that was not right. Oh my gosh, don't listen to me. I'm going to put a nice solid dot on the number 2 on what I think x is. All right, moving on to our next one. It says, it was very cold in Canada on Monday. On Tuesday, the temperature dropped 1 degree and was -2. So what is x, the temperature on Monday? So again, first thing I want to find is the variable and what it represents. So x is representing the temperature on Monday. So on both of my examples, I'm going to put an M for Monday. put my m's right here under my x, and then it says, on Tuesday, the temperature dropped 1 degree and was -2. So this right here, the -2, is our temperature on Tuesday. So I know that it dropped 1 degree and became -2. So that dropped 1 degree, again, is an additive word. And when I look at both of my equations, they're both additive equations. One is x minus 1, and the other one is x plus 1. So when I look at these two equations, believe it or not, they're actually equivalent equations. You might be thinking, but they have different numbers and different operations. So here's what we have to remember. I can change this equation right here, this subtraction equation. If I do LCO and I leave it, change it, opposite, it becomes x plus -1, just like this one over here. So both equations are correct. So that's why I said up here on the very first one, we can't just see this dropped one and assume it's subtraction, because they might try to trick us by giving it to us as the addition expression, the addition equation. So both of these are correct. So I'm just going to go with my plus -1 over here, just because it has more room around it. We're going to solve it using our tiles. So again, this dark line right here means equals. On the left side of my equal sign, I have a positive x tile and a negative unit tile, so a shaded in tile. On the right side, I have two negative tiles. So 1, 2. My goal, again, is to isolate that variable, to isolate x. So I have to get rid of what's bothering it. So right now there's a -1 bothering it. So the opposite would be a +1. What I do to this side, I have to do to the other side. And then I can go make my 0 pairs. So on the left side, I have 1 0 pair to make, and all that remains is x. On the right side, I have a 0 pair to make, and what remains here is -1. So x equals -1. Let's solve it algebraically. So I have x plus -1 equals -2. So again, I'm going to build my t-chart, and I need to circle what's bothering the x. So what's bothering the x is plus -1. So the opposite would be to subtract -1. What I do to one side, I have to do to the other side. My plus -1 and my minus -1 are going to cancel each other out. So I have x and then equals -2 minus -1. I'm actually going to rewrite it like this over here on the side, because when I subtract a negative, again, I want to use LCO to make it a little bit nicer for me. So it's -2 plus 1. My signs are different, so I need to subtract and keep the sign with the most. So my sign with the most is negative. 2 minus 1 is 1. So again, I get x equals -1. To check, we're going to rewrite our original equation. So x plus -1 equals -2. I'm going to substitute in what I think x is. So that would be -1 plus -1 equals -2. -1 and -1 are the same sign, so I just need to add and keep the sign. So 1 plus 1 is 2. My sign is negative, so -2 equals -2. So for my check, I'm going to go put a closed dot on -1. So this will be -2, -1, boom, a nice closed dot. Our next problem says that Kimberly ate 4 Jolly Ranchers, and together she and her friend Kinsey ate a total of 7 Jolly Ranchers. So I want to know, how many Jolly Ranchers did X, Kinsey, eat? So X represents Kinsey. I'm going to put a KIN for Kinsey underneath both of my X tiles. Then the next thing it says is that together she and Kinsey ate a total of 7 Jolly Ranchers. So when I look at my two problems here, I see that one of them is a subtraction problem, one of them is an addition problem. And the total goes in a different place for a subtraction problem and an addition problem. In a subtraction problem, the total is the first number. So that means in this equation, the total is x, but we know that x represents Kinsey, so it can't represent both of them. In our addition problem, the total is always the answer to the addition problem. So this would make sense. The total is representing 7. Kinsey is X. Kimberly is 4. She ate 4 Jolly Ranchers. So this is our equation here. So again, we need to draw with our tiles. So on the left side of my equal sign, I have 4 plus X. So 1, 2, 3, 4 positives and an X tile. On the right, I have 7 positives. So 1, 2, 3, 4, 5, 6, 7. So again, I need to isolate the variable, get rid of what's bothering X. And what's bothering X right now are 4 positive tiles. So the opposite would be 4 negative tiles. What I do on one side, I have to do on the other side. So 1, 2, 3, 4. I'm going to go make my 0 pairs. So there's 1, 2, 3, 4 0 pairs. So all that remains is X. And then my 0 pairs over here. So all that remains are 1, 2, 3 positives. So X equals 3. Solving this algebraically, 4 plus X equals 7. I'm going to make my t-chart. What's bothering the X is this positive 4. So the opposite would be negative 4, which looks like subtracting 4. These are going to cancel each other out. So I have X equals 7 minus 4, which is 3. To check, I'm going to use again my original equation. So 4 plus X equals 7. I'm going to substitute in what I think X is. So this will be 4 plus 3 equals 7. 7 equals 7. Check, we are correct. And then I'm going to put a nice closed dot on 3 for my graph. All right, last one says Finley took $5 out of her piggy bank and had $2 left. How much money, X, did she have in the bank before her withdrawal? So X represents her before, so I'm going to put a B for that. Then it says she took $5 out of her piggy bank and she had $2 left. So in this one, $2 left is like what's remaining. This is what she took out. So again, we've got an additive word here. Okay, so when I look at my 2 equations, I see one of them is 2 equals X minus 5, and the other one is 2 equals X plus 5. So remember, B represents what she had before. So both of them have X, and then it's either plus or minus. So if she is taking out $5 and then somehow ending up with $2, it would make more sense to have X minus 5 equals 2. This is what she had before. She got rid of $5 and she has $2 left. This problem would be saying this is what she has before. She adds $5 to it, or she puts $5 in and somehow she now has $2. That one doesn't make much sense. So let's use this one right here. So I'm going to set up my tiles. So on the left side of my equal sign, I have 2 positives. So 1, 2. On the right side, I have X minus 5. So here's an X tile and 5 negative tiles. 2, 3, 4, 5. Okay, so now I need to, again, isolate the variable, get rid of what's bothering the X. So it would be my 5 negatives. So the opposite would be 5 positives. 1, 2, 3, 4, 5. What I do to one side, I have to do to the other side. 1, 2, 3, 4, 5. Now to make my 0 pairs. So what remains on the right side is X equals, and then I don't have any 0 pairs to make on the left side over here. I now have a total of 1, 2, 3, 4, 5, 6, 7. So I get that X is equal to 7. Solving this algebraically, I have 2 equals X minus 5. Again, what's bothering the X here is this minus 5. So the opposite would be to add 5 to both sides. My 5s are going to cancel each other out. So I'm left with 2 plus 5 is 7 equals X. Again, let's check. Let's rewrite our original equation. I'm going to substitute in what I think that X is. So 2 equals 7 minus 5. 7 minus 5 is 2. So 2 equals 2. We are correct. And then last but not least, I'm going to go put a nice closed dot on the number 7.